Okay, week 3 of John's Weekly for Physics 112 with instructor David Weaver. Week 3 consisted of mainly working on Project 1 that was due this week, week 4, due the end of week 3. Drove around Walmart. Went to Walmart 3 times, went to Radio Shack a couple times, spent about $40 in parts. First camera, couldn't figure it out, broke it or something. Second camera got a little bit better. Third camera, finally was able to get a charge. Fourth, fifth, and so on, better and better until the sixth one was a charm. Got to meet up with one of my teammates, Tim Snyder. We worked on it at his place first. Well, he worked on his. I was helping. Yeah. So then I came home and then worked on mine later on. Spent the rest of the week working on mine. Then we were texting each other back and forth through the week. Learned a lot of stuff this week, mainly about the coil gun. I never knew about this project before, and it did involve a lot of physics. It was pretty cool. Learning about magnetism, how the BB propelled out of the barrel. And then another thing I learned was the electrical force is stronger than gravitational force. That was really interesting. About 2 to the 2.22 times 10 to the 39th power. That's how stronger it is, the electrical force versus gravity. Then the questions were for you this week were, what do you do with tape when you bring to Denny's? You mentioned in one of your videos that you're like, you never know when you need tape at Denny's. So I always bring a roll of tape to Denny's. So I'm just curious, what do you do with that? Another question was, in the resistor video, in the example you had was resistor A gives off light, then you had resistor B and C in parallel, both giving off light. I understood when all bulbs are screwed in, A is brighter than B and C. I knew that, but you said when you unscrewed C, you explained that B was brighter than A. That I did not understand. And a program that you showed us last week was the electrical circuit program, a website. That's one of my favorite links. How you can build things and put light bulbs in, resistors in, ohms, how much resistance. I used that as a demo to see if you were correct, saying that A will be dimmer than B if C was unscrewed. So I put it an exact diagram like you did, but I noticed when I unscrewed C, B and A were equal in intensity, and when I put all three in, A was brighter than B and C. So that was another question I had on top of your bringing your tape to Denny's. Now, I'm still writing in my notebook, and I know you wrote something about people losing their stuff in their backpack, how they wrote their notes and everything, but I still believe in writing the old-fashioned way. I know this is a technology class where we use a lot of technology, but I still have my notes, this week's notes, such as, we talked about electrical and gravitational. Electrical. I probably can't see that, it's too bright. This is my notes on electrical and gravitational. What I really got out of that, like I said earlier, was electrical force is stronger than gravitational force. I put, wow. In fields versus forces, you explain that a sheet metal and a bowling ball is put on this sheet metal, and it collapses the sheet metal. And then you explain the field force that if you put a golf ball near the bowling ball, the golf ball will follow that bowling ball into this concave dip in the sheet metal. So that was pretty cool. And then you explained same sheet metal, but one corner had a positive charge and the bottom corner had a negative charge. And let's say you put a positive charge on the sheet metal, and that from the positive to the positive there will be a hill, and the positive to the negative area there will be a valley of some sorts. So that was interesting. And then I believe I asked you about the questions onto the resistors. How A will dim up and B will get brighter when C is unscrewed. So, and then the semiconductor in physics, semiconductor physics. That was pretty interesting too. How you talked about NPN and then PNP. I actually remember them talking about that when I used to work in the semiconductor industry, but I never truly understood it until now, until you explained it, believe it or not. But they did talk about that a lot. So, the NP, the forward bias, that was, thank you for explaining that, I understood that now. N fills to the P type, so that's forward bias. And we can reverse that, and that would be called reverse bias. So, that was cool. And then you showed us the coil gun, which I thought was very complex to understand. I had to slow it down. Like when you were trying to explain the flow path from the beginning of the charge system, I had to slow it down and play it a couple times to understand that. So this week was busy. My like I said, I got with my lab partner Tim Snyder. Kate did not get with us, but we made a PowerPoint presentation for our whole group that I believe we will send to you, and I will put it in the document archive to show you that that we did this as a group, but we also did it as an individual. We each made our own guns, but at the same time we still collaborated with each other online through text also and in person on this project. That's why it was a group project, but also an individual project. I have this is my setup here. As you can see, this is my little shooter. Push button, firing switch, outside barrel. I enclosed it in a size 7 Converse shoes. And here's my wiring. And you see the magnetic coil. I hardwired the battery. Here goes my little BB. Capacitor. Camera board. Kind of taped it up there to keep it up. I have a video I'll show you. I'll send that to you. Or put it in my blog or YouTube, one of those places. I have multiple videos of my build up, some of it. But it was a neat project, and I drew some diagrams, schematics, as you said you wanted to try to sell the product if I was going to sell to somebody. I drew dimensions on there as much as I could. Outside view. And I'm not the best schematic drawer, but I tried. So it's horrible, actually. That goes with that. I think that's it. It was a busy week for all of us. A lot to do. Well, that's it. Take care.